Have you ever wondered how weather patterns are formed and why they change so abruptly sometimes? Well, the answer lies in the fascinating world of air masses. These are vast bodies of air that maintain uniform temperature and moisture characteristics across thousands of kilometers. Imagine a gigantic bubble of air that's the same temperature and humidity no matter where you are inside it. Now, these air masses don't just form randomly. They're primarily created over regions with consistent surface features, such as the chilled expanse of the Arctic ice caps, the scorching Sahara Desert, the deep blue of the Pacific Ocean, or the lush Amazon rainforest. Each of these diverse landscapes imprints its unique stamp on the overlying air, creating air masses with distinct characteristics. But how does this happen? It's all thanks to key processes like turbulence, convection, and radiation. Turbulence, with its chaotic air movements, mixes the air, helping to create a uniform environment within the air mass. Convection, the rising and falling of air, helps distribute heat or cold throughout the air mass. And radiation, the transfer of energy via electromagnetic waves, allows the Earth's surface to heat or cool the overlying air. The Arctic ice caps, for instance, radiate little heat, helping form an exceptionally cold and dry air mass. In contrast, the Sahara Desert, with its intense heat, forms a hot, dry air mass. The oceans, with their vast expanse of water, create warm, moist air masses, while dense forests contribute to the formation of cool, humid air masses. These air masses, once formed, don't just sit idle. They move, carried by winds, and as they travel, they carry their temperature and humidity characteristics with them. This movement and interaction of air masses play a crucial role in influencing our global weather patterns, leading to the diverse climates we experience around the world. So, it's the formation of these air masses over diverse landscapes that sets the stage for our weather patterns. In the next scene, we'll dive deeper into the classification of these air masses and how they further impact our weather. Now that we know how air masses form, let's talk about how they are classified. Air masses are primarily categorized based on 4 key parameters: temperature, moisture content, stability, and source region. These parameters give us distinctive types of air masses, each with its own unique characteristics. For instance, we have polar air masses, notorious for their cold temperatures, and tropical air masses, known for being warmer. But the classification doesn't stop there. Each of these categories is further subdivided. For example, we have continental polar air masses and maritime tropical air masses. The continental and maritime labels indicate whether the air mass originated over a land or sea surface, respectively. These classifications are not just for academic interest, they have practical implications too. The classification of air masses helps us understand the kind of weather they might bring with them. Let's take a closer look at some specific air masses and their unique characteristics. The Arctic air mass, forming above latitude 70 degrees north, is exceptionally cold and dry. It's known for creating significant thermal inversions and minimal turbulence, shaping its unique meteorological characteristics. Polar air masses, on the other hand, generate over the temperate zones of oceans and continents. They are seasonal chameleons, becoming unstable in summer over continents due to heating from below, leading to weather phenomena like fog and frost. Now, let's journey to the subtropics. Here, we find the tropical air masses, which are warm and can be split into maritime, which is moist, and continental, which is dry. Their interaction with land and sea drastically affects their stability and moisture content. It's fascinating how each air mass, with its unique set of characteristics, contributes to our global weather patterns. So, how exactly do these air masses influence our weather? Well, let's start with unstable tropical air masses. When they move over land, the warm, moist air rises, cools, and condenses, forming towering cumulus clouds. These are the birthplaces of thunderstorms, complete with lightning and heavy rain. Now, let's consider stable polar air masses. When these move over warmer surfaces, they don't easily mix with the warmer air beneath. This stability can lead to persistent foggy conditions, especially during the colder months when the ground is still warm. You see, the key here is movement. Air masses don't stay put. They're constantly on the move, driven by the rotation of the Earth and the larger patterns of atmospheric circulation. When they move, they take their temperature and moisture characteristics with them, influencing the weather in the regions they travel over. It's the movement and interaction of these air masses that create our diverse weather patterns, from thunderstorms to foggy mornings. Now, let's shift our focus to atmospheric fronts, the transition zones between different air masses. Imagine a battleground where two contrasting armies, or in our case, air masses, meet. These zones, or fronts, are where the weather drama unfolds. Atmospheric fronts are categorized into three main types: cold fronts, warm fronts, and occluded fronts. Each has its unique way of stirring up the weather. Cold fronts, for instance, are like abrupt party crashers. They can cause sharp temperature drops and even severe storms. On the other hand, warm fronts are the gradual shifters. They're known to produce widespread cloudiness and precipitation, a bit like a slow drizzle that sets in and stays. Finally, we have the occluded fronts. These occur when a cold front overtakes a warm front, leading to complex weather systems and varied precipitation. Atmospheric fronts, with their distinctive characteristics, are responsible for some of the most dramatic changes in our weather. Let's examine these atmospheric fronts in more detail. Our first stop is the cold front, the boundary where a colder air mass replaces a warmer one. These abrupt transitions can cause temperatures to plummet and often lead to severe weather conditions such as thunderstorms and heavy rainfall. Next, we have warm fronts, which occur when a warmer air mass slides over a cooler one. These transitions are more gradual and typically result in widespread cloudiness and light, persistent rain. Last but certainly not least, we have the occluded fronts. These are fascinating phenomena that occur when a cold front overtakes a warm front, a process known as occlusion. This can lead to complex weather systems with varied types of precipitation, from drizzle to snow, depending on the temperatures of the involved air masses. And that's how the dance between air masses and atmospheric fronts shapes our weather, making meteorology a truly dynamic and fascinating field.